Welcome to Tennessee's at-home learning series for math. Today's lesson is for all our 6th graders out there, though all children are welcome to tune in. This lesson is the 4th in our series. My name is Reggie Caruth and I'm assistant principal here in Tennessee Schools, and I'm excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see any of our previous lessons, you can find them on Tennessee Department of Education website at www.tn.gov/education. You can still tune in to today's lesson if you haven't seen any of our previous lessons, but it may be more fun to go back and watch our other lessons since we'll be talking about things that were previously learned. Today we'll be learning about using a given set of numbers to determine what numbers will make an equation or inequality true in mathematics. Before we get started, to participate fully in our lesson today, you'll need the following: pencil, paper, and a calculator if you have one. You ready? Let's begin. So again, today we'll be working with given sets of numbers to find out if any of them make our equation or inequality true. Some numbers will be whole numbers, others will be fractions, and we may even see some decimals. This may be a review for you, so I can't wait for you to help. Let's start out with remembering a few things about equations and inequalities. Again, you can use a calculator if you like. Okay, I need your help in answering a few questions and finding a few solutions. First of all, how do you know if we have an equation? Again, I'm going to let you think about that. How do you know if we have an equation? If you said it has an equal sign, pat yourself on the back because you are correct. All right, so here's another one. How do you know if it's an inequality? Again, think about it. How do you know if it's an inequality? You may have said it has less than or greater than. We use the following symbols to represent our inequality: greater than, less than, greater than or equal to, and less than or equal to. These symbols coming back to you? All right, so let's see what we remember. Go grab some paper and a pencil and let's do some practice problems while I erase my board. Okay, so let me know if the following equation or inequality is true or false. Again, I want to know if the following equation or inequality is true or false. Here's my first problem. 5 squared plus 9 equals 19. 5 squared plus 9 equals 19. I want you to solve this and let me know if this is true or false. Let's check it. So I know 5 squared is 5 times 5, which is going to give me what? 25. And 25 plus 9, does that equal 19? No, because I already have 25, and if I add 9 more to that, that does not equal 19. So that one is false. Let's try another one. We have the problem 24 minus 16 is less than 10. I want to know if this is true or false. Hopefully you said true. Let's test that out. So 24 minus 16, what does that give me? Correct, 8. And is 8 less than 10? Correct, you're on the ball. Let's try another one. This next problem is 2 times 3 plus 4 squared equals 38. I'm bringing back some things from our previous lessons. I want to see if you can get it. I want to know if this is true or false. We can test this out. So what do I start with first? Remember this from our previous lesson. Exponents. So I know I have 4 times 4, which is going to give me 16. I'm going to bring everything else down. My parentheses, my plus, my 3, and my times 2. So now my problem reads 2 times 3 plus 16. What do I do next? Inside of parentheses. So I'm going to do 3 plus 16, which is going to give me 19. Bring down my parentheses and my times 2. So now my problem is 2 times 19. What's 2 times 19? 38. So this one is true. Good job. Let's do one more. Activate those brains. We're going to do 3 cubed is greater than or equal to 29. Again, I want to know if this is true or false. Let's see. 3 cubed, I know is 3 times 3 times 3. 3 times 3 times 3 is going to give me 27. And rewrite my problem. 27 is greater than or equal to 29. Is 27 greater than or equal to 29? No, so this has to be false. Good job activating your brains. I'm really excited about diving into this lesson. So today we will see variables in our equations in our inequality. Again, I want to know, what is a variable? I'm going to give you a second to think about it. What is a variable? A variable is a symbol, such as a letter, that represents a number. It's almost like it's a placeholder for a number. We're also going to have a set of numbers for each of our problems today. We're going to determine if any or all of the numbers make our equations or inequalities true. Are y'all ready for some math? Let's go. So I'm going to throw some problems up on the board, and then I'm going to throw a set of numbers. I want us to substitute each number into our equation to see if which one of these numbers is going to make this equation true. So here's my set of numbers we're going to be working with today. 3, 6, 15, 16, and 44. So here's our first equation. We're going to figure out which number is true. X plus 26 equals 32. So now what we're going to do is we're going to start substituting these numbers in for x to figure out which one of these numbers is going to make our equation true. So I'm going to start with my first number in my set, 3. I'm going to substitute 3 for x. So 3 plus 26, does that equal 32? No. 3 plus 26 is 29, so that one can't be it. Let's look at my next one. I'm going to substitute 6 in for x. 6 plus 26 equals 32. Does 6 plus 26 equal 32? Yes. 6 plus 26 is 32. So these are equal. So 6 is my answer for my solution. Got that? Let's try another one. We're going to use these same numbers to substitute. So this equation is going to be m minus 12 equals 32. So now I can start substituting in for m. I'm again going to go through my series of numbers. So I'm going to substitute 3 for m. 3 minus 12 equals 32. Well, 3 minus 12, does that equal 32? No, so 3 can't be one of my answers. So now I'm going to substitute 6 in. 6 minus 12, does that equal 32? Nope. That's not my solution. Let's try 15 minus 12. Well, 15 minus 12 is going to give me what? 3. And I know 3 doesn't equal 32, so 15 is not it either. Same thing with 16. That's going to give me 4. It's not it. So the last one I have is 44 that I can substitute for. It should be my answer, but we're going to still substitute to be sure. So 44 minus 12, does that equal 32? It does. So 44 is the solution. Good job. Let's try another one. Our next problem is going to be 4 squared equals y. So again, I want to know what number in this set is going to make this equation true. Well, what is 4 squared? I know that 4 squared is 4 times 4, which is going to give me 16. So I know y has to equal 16. So my solution for this is actually 16. You want to try another one? That's good. The last one we're going to try is going to be n over 4, or n divided by 4, equals 11. So now I can start substituting for n. Substitute 3 for n. 3 divided by 4 is going to give me 11? No. So I know that can't be it. Do the same thing for 6. Substitute 6 in for n. The 6 divided by 4, is that going to give me 11? Nope. Keep substituting. 15 divided by 4, is that going to give me 11? Nope. Keep going. 16 divided by 4, is that going to give me 11? Nope. It's going to give me 4. So the last one is going to be 44 divided by 11. This 44 divided by 4, is that going to give me 11? Yes, so 44 is my solution. I can even check it. 4 goes into 4 one time. 4 goes into 4 one time. So that is correct. So now we're going to do the same thing and use these same series of numbers. We're going to do them with inequalities. Let's try this one with an inequality. You all are doing good. So the inequality we're going to do is h plus 8 is greater than 30. H plus 8 is greater than 30. So now I can start substituting for h for my series of numbers. So I'm going to start off with substituting 3 for h. 3 plus 8 is greater than 30. Well, what's 3 plus 8? That's 11. Is 11 greater than 30? No, so 3 can't be it. Now I'm going to substitute 6 for h. 6 plus 8 is greater than 30. Well, what's 6 plus 8? 14. Is 14 greater than 30? No, so 6 can't be it. Let's keep substituting. Let's hang in there until we find our solution. Let's try 15. 15 plus 8. Is 15 plus 8 greater than 30? No, it's 23. We're getting closer, but we're not there yet. I should automatically know, since 16 is one more than 15, this is just going to make this solution one more, so that's going to be 24. So it can't be 16 either. So all I have left is 44. 44 plus 8, is that greater than 30? Well, 44 plus 8 is 52. Is 52 greater than 30? Correct. So 44 is my answer. Good job with working with inequalities. Let's do some more. My next inequality we're going to do is 2x, or 2 times x, is less than 15. I'm going to do the same thing, but now I'm going to start substituting in for x. So again, I have 2 times, I'm going to substitute x for 3. So 2 times 3 is less than 15. Well, what's 2 times 3? Correct, that's 6. Is 6 less than 15? Yes. So that's one of my answers for my solution. But I wonder if there's more. Let's check. I'm going to substitute now 6 for x. 2 times 6, that's going to give me what? 12. Is 12 less than 15? It is. So with this one, I have more than one answer. Let's keep checking to see if there's any more. This next one I'm going to plug in 15. We'll substitute 15 for x. 2 times 15 is going to give me 30. Is 30 less than 15? No. So my answers to my solution is 3 and 6. So I don't even have to keep checking. Y'all got that? Let's try another one. My next problem I'm going to try is 42 is less than or equal to 50 minus a. So what am I going to substitute for this time? I'm going to substitute for a. So I'm going to go through my series of numbers and start substituting and figure out which one of these or how many of these is going to make this inequality true. So I'm going to start with 3. 42 less than or greater than 50 minus 3. 50 minus 3 is going to give me what? 47. Is 42 less than or equal to 47? It is. So 3 is one of my answers. But I want to keep checking to see if there's more. So I'm going to do the same thing. So now I'm going to substitute 6 for a. 50 minus 6 is going to give me what? 44. Is 44, so let's look at it. 42 is less than 44, is that correct? Yes, so 6 is also one of my answers to my solution. Let's keep substituting. I'm going to substitute 15 for a. What's 50 minus 15? 35. Now let's look at our inequality. Is 42 less than or equal to 35? No, so 15 can't be it. 16 or 44 can't. So my solutions is 3 and 6. Good job. Let's do one more. So my next one, I'm going to do 30 over n, or 30 divided by n, is greater than 2. So what am I substituting? I'm going to substitute n. So go through my series, substitute 3 for n. 30 divided by 3, is that going to be greater than 2? Well, 30 divided by 3 is going to give me 10. Is 10 greater than 2? Yes. So 6 is one of my answers. But let's keep checking. Next, I'm going to substitute 6 n for n. 30 divided by 6, is that going to give me, is that greater than 2? Well, what's 30 divided by 6? 5. Is 5 greater than 2? Yes. So that is correct. Let's keep checking. So I'm going to substitute 15 for n. $30 divided by 15, is that going to be greater than 2? Well, what's 30 divided by 15? It's 2. Is 2 greater than 2? No. 2 is equal to 2. So this can't be correct. So 15 won't work, 16 or 44. So my solutions are 3 and 6. Y'all doing great. So for the following problems, we're going to substitute numbers in a set for the variables and determine which variables make the equation or inequality true. I want you to help explain how you know what your answer is correct. So here's your problems we're going to work through. I'm going to put your problems on the board, and I'm going to give you each series of numbers. The first problem is x is less than 4 given, here's our series of numbers, 0, negative 1/2, 5, negative 6, 2 1/3, 4, and negative 10. I want you to try this problem. I'm going to give you a second to try it. All right, so let's start substituting. So I'm going to substitute first 0 for x. So I have 0 is greater than 4. Is 0 greater than 4? Oh, I'm sorry. 0 less than 4. Is 0 less than a negative 4? I'm forgetting my negative. I'm sorry, y'all. So now I'm looking at the problem. X is less than negative 4. Is 0 less than negative 4? It's not, so 0 is not part of my answer. So now I'm going to substitute negative 1/2. Is negative 1/2 less than negative 4? Nope. Same thing here. I'm going to now substitute 5 in for x. Is 5 less than negative 4? Nope, I'm gonna keep going. Let's try negative 6. Is negative 6 less than negative 4? Yes, it is. So here's one of my solutions, but I'm gonna keep testing my other ones. Now I'm gonna substitute 2 1/3. Is 2 1/3 less than negative 4? Nope, so that's not it. The next one is 4 less than negative 4. Nope. And my last one, negative 10. Is that less than negative 4? It is. So my solutions is negative 6 and negative 10. Got that? Let's do another one. My next problem. My next problem is going to be 2/3 times m is equal to 4. Given these series of numbers, 0, 2, 6, and 9. So now we're going to start substituting. When I substitute 0 for m, I have 2/3 times 0 equals 4. Well, 2/3 times 0 is what? 0. Does 0 equal 4? Nope. Now I'm going to substitute 2. So 2/3 times 2 equals 4. 2/3, I like to set my whole number as a fraction, times 2 over 1 so I can multiply. Great. So 2 times 2 is 4. 3 times 1 is 3, so 4 over 3. Does 4 over 3 equal 4? Nope. So that one can't be it. So now I'm going to substitute 6. Same thing, 2/3 times 6, and I'm going to make that 6 over 1 so I can multiply my numerators and my denominators. 2 times 6 is going to give me 12. 3 times 1 is going to give me 3. And when I divide 12 divided by 3, that's going to give me 4. Does 4 equal 4? Yes. So my answer to this solution, to this equation, my solution to this equation is 6. So my last one. Is going to be 5t equals 24 given 4.8, 24 fifths, and 4 4/5. So I'm going to start plugging in, or substituting. So I have 5 times 4.8 equals 24. Does that give me 24? It does. So now I'm going to continue to, wait a minute, I see something. I want to see if you see it. I'm going to give you a second. All of these, hopefully you saw it, all of these are equivalent. 24 over 5 is 4.8. And 4 4/5 is 4.8. So all of these are equivalent. So all of these have to be answers to my equation. Did you all notice a pattern with solutions to equations and solutions to inequalities? Well, with equations, there were only one solution, and with inequalities, there could be multiple solutions that will make the inequality true. Great work today, you all. We reviewed ways to determine if equations and inequalities were true given sets of numbers. I hope you're seeing the way substitution can be used to help determine if solutions are true. You sure did a great job today, y'all. After the video, you'll have some problems to practice on your own. Good luck and do your best. Boys and girls, I've enjoyed doing mathematics with you today. Thank you for inviting me into your home. I look forward to seeing you in our next lesson in Tennessee's At Home Learning Series. Goodbye.